All right, hello everyone. 1, 2, 1, 2. Is the recording started? Okay. So today we're gonna talk about how we auto-remediate infrastructure in our OpenStack cloud. Uh, Here we go. First question. All right. So about us, my name is Mikita Gubenko. I'm an infrastructure engineer at Mirantis. Together with me, Alexander Sakno, who is also platform engineer at Mirantis. We are a part of professional services team at Mirantis, and for the most part, our presentation will be based on customer engagement we are having with Semantic Cloud Platform Engineering team. All right, so by show of hands, how many of you never heard about OpenStack before? Just one? Okay. How many of you use it in production? Right, some hands. And how many of you here just for the pizza? Here we go. All right, just want to know the audience. Okay, let's go ahead and start. So we'll cover this agenda today. We'll talk about our semantic environment, what OpenStack cloud we're running. We'll talk about monitoring ecosystem, what monitoring solution and tools we use. We'll talk about how we actually get into the auto-remediation and self-healing. We'll remind you what OpenStack is and its architecture briefly. Of course, we'll talk how what auto-remediation use cases we came up with for our OpenStack cloud. And at the end, we finally show some screencasts with one of the examples of the auto-remediation we implemented in our OpenStack cloud. All right, environment. Semantic has a hybrid cloud. It's basically a mix of OpenStack and AWS. The OpenStack infrastructure is for regions across the globe. It's hundreds of racks and thousands of compute nodes. AWS infrastructure is also rapidly growing. We have tens of thousands of cores. But today let's focus on OpenStack cloud since that is what the title of our presentation says. Monitoring system. Since monitoring is the essential part of every production environment, we use a bunch of tools. Zabbix is the main one. We also have things like Prometheus, Nagios. We use PagerDuty for pages and on-call schedules. We have Volta, which is a login monitoring and metering platform. And under the hood is just a Logstash, Kafka, Elasticsearch, and FluxDB, Grafana, Kibana stack, like basic stuff. We also have things called synthetic transactions. It's just a functional test against our environment, like creating a VM, assigning a floating IP to it, and checking if it all works. We also have health dashboards, which is structured way on how our environment is doing. It consists of like the most important metrics. And since the Zabbix is our main monitoring tool, here's how its architecture looks like. It's basically every data center is managed by standalone Zabbix proxy. It's very like standard stuff. So Zabbix now has a few thousands of monitored hosts, hundreds of thousands of items. We monitor things like processes, services, resources, APIs, performance and utilization metrics. We do alerts via email, Slack, and Jira. It also integrated with PagerDuty, as I said, and recently we added StackStorm integrations for auto-remediation workflow and self-healing actions. All right, the boring part is over. Let's get into it. So it was only 3 of us who were running this relatively big private cloud, and we were doing it in addition to feature deliverables like adding new data centers, adding new services, like doing the upgrades. We were on call all the time. So we were doing like we reacted to alerts, we fixed the outages, we wrote RCAs, wrote playbooks and stuff. So our incident response workflow looked like this. So based on severity, you can either get the call from PagerDuty, or if the problem needs to be fixed right away, or you'll get the email and you can work on the problem during business hours if it's not hurting the production environment. And so while working on outages, we started to realize that working on time we spent on outages is hurting our productivity in other areas. So we started to identify some kind of operational patterns which we should automate in our day-to-day operations. That's how we actually get into the auto-remediation. So for us, auto-remediation is an approach to automation that responds to events with actions to prevent, help fix, or fix the issues. And in addition to that, event-driven automation is an approach of executing action workflows based on operational events like alerts. The simplest example of what auto-remediation is when your disk space is filled with the logs from some service. And why do we need to wake up engineer to fix that if like the simplest script can fix it automatically and in the morning let you know that you need to fix like log rotation on this box, right? So that's how the updated workflow looks like. So if the problem is known, you just auto-remediate it. Like if it's basic stuff, I mean, we don't need to wake up engineers. And if that's not me, okay? So if the problem is unknown or auto-remediation did not fix the problem, we fall down to the same workflow we had before, but automation will help us to collect as much debugging information as possible. So the engineer that will start working on the problem will do it like quicker because he'll have additional information like logs, monitoring metrics, some graphs regarding this issue. So we call it like assisted troubleshooting or facilitated troubleshooting. So what to automate? When we think what to automate first, I like to draw this picture. It's called leftover principle. Basically, functions that you cannot assign to machines, humans should carry out. So if the problem happens frequently and it's easy to automate it, we need to do it right away. Things like service restart, logs cleaning, VM reboot. I mean, it's very easy to automate, so we need to do it right away. Things like that happens rarely but easy, you should also automate them at some point. Things like restoring RabbitMQ clusters, restoring MySQL replication, and so on. The difficult stuff, I suggest to create tools around it, like for assisted troubleshooting, and go from there, just helping the engineer to fix the problem, not trying to solve them. All right, so what automation will improve? You will decrease your MTTRs, which is mean time to repair. You will resolve your outages quicker, or even prevent them. You will improve your SLAs. The engineering productivity will increase because they won't deal with outages as much as before. Of course, the number of pages will go down. And as a result of previous points, sleep time will also improve because, I mean, and since I'm the father of little baby, trust me, this is like a crucial one. Okay, some things to keep in mind. So the bigger scale you have, the bigger profit you will get. Like you might think I have this one RabbitMQ cluster in my OpenStack, and it breaks like once a year. Why do I ever want to automate around it? But at Mirantis, we deploy OpenStack to hundreds of customers with hundreds of RabbitMQ clusters. So it's a bigger scale. It pays over time. Be deliberate in detecting the exact issue of outage. You want to run your fixed actions against the problems they are solving. For example, you don't want to rebuild MySQL replication if your MySQL process dies. You can just restart it, right? So do not over-automate. Leave things like database corruptions or network outages alone, because I mean, humans are still better than the scripts, well, for the most part. So set your maintenance windows properly. This one actually got the story behind. Right after we implemented auto-remediation of our Nova Compute service in our OpenStack cloud, one of our engineers was doing the upgrade, and it required the Nova Compute to be stopped. But since he set the wrong time frame in the Zabbix maintenance window, Zabbix was still firing actions. So when he stopped the Nova Compute, in a couple of minutes, all the data center was back up, like all the Nova Computes were back up. And after a couple more tries, with the same outcome, he realized that something's going wrong here. So be careful not to run actions when they don't need it. Every alert and action matters. So every alert should be actionable, should follow up with the ticket or auto-remediation action or permanent fix. You don't want, I mean, there's no sense to get the alert you ignore, right? And just a reminder, permanent fix is still better than creating auto-remediation actions, right? Okay, so what is StackStorm? While looking for the open source solution for auto-remediation, we actually saw the Meetup from the Netflix guys, and we like the idea, we like the solution. So StackStorm is open source event-driven auto-remediation framework. Why do we use it? It ties together our monitoring solutions and our infrastructure that we run actions on. It's also a powerful framework to create our auto-remediation workflows. It has like Mistral workflow engine included and stuff. It also contains predefined building blocks called packs, and it has integrations with Nagios, Sensu, Jira, Slack, you name it. And of course, it's easily extendable, so you can write your own actions or your own integrations, your own sensors. So this is how it fits into our infrastructure. We have our monitoring solutions in the top, which trigger the events, and based on some set of sensors, rules, or workflows, StackStorm either trigger section to the infrastructure, like fix something or do something or I don't know, prevent something, or does like some sort of notifications to engineer using like different sources. All right, OpenStack architecture. So the things that I was talking about can be applied to every system and OpenStack as well. Since OpenStack has like many moving parts, it's very useful for us to auto-remediate it. As many of you know, OpenStack architecture is very easy. It's like this. It's like 2 + 2, right? But to be serious, OpenStack consists of like hypervisor hardware and control plane. And the control plane is, the bunch of microservices. Each one serves the different purpose. We have like compute, identity, network, image, and storage. So, right, next up, Alex will talk more about what OpenStack use cases we came up with for auto-remediation. Thank you.
All right, thank you, Nikita. Hi, everyone. My name is Alex Oknov. So let's get to the OpenStack use cases and see how it can actually benefit from the auto-remediation. So we kind of gathered a list of use cases, which is kind of a list of pain in the asses in our day-to-day operations. There are some really basic use cases which can be implemented within a couple hours, and there are some more advanced. The good thing about it is that pretty much all of them are quite generic, and they can be reused for any other services outside of OpenStack. So the basics are pretty much clear. I guess everyone had either the problems with the disk space filled up, or some bug in the service that failed, and on-call engineers had to go and restart it manually until the bug is actually fixed. That's not cool, and this part can be really automated using the StackStorm. So let's go over the advanced cases, and I'm just like gonna I just want to share our experience and visions about the auto-remediation process and what is the benefit you can actually get from the StackStorm. So the most value, I would say, well, at least for us, that you can get from the event-driven automation, it's basically assisted troubleshooting or rich alerts. No matter what happens, you want to get as much information as possible before you actually start troubleshooting. And it can be like anything, like the log files, the links to Kibana or Grafana dashboards with related metrics, or even some information about a related service that can affect your outage. And if this information come in the email with the alert, it helps a lot to the engineers. The other thing that's worth to mention here is it can be integrated with the chat-ops, and it basically can provide you, like the bot can actually provide you a guide like through resolution process, or like wait for the engineering command to actually start the auto recovery. So the next is RabbitMQ and MySQL, because these are the core of the OpenStack, and this is quite a big field for the automation. For example, quite recently we had a problem with the RabbitMQ. Basically, the third-party component had a bug, and it just bombarded Rabbit with the messages. It basically was about like hundreds of thousands of messages in a queue, and Rabbit cannot just survive under it. So we just implemented an action on the StackStorm to like wipe all the messages above some limit, and just waited until the bug is actually fixed in the component. Another use case that we keep in mind is, well, and this is kind of relevant for both like RabbitMQ and MySQL, is that when the node is actually go down and you have to rebuild it. Like for us, we're running these services on top of virtual machines, and these VMs are controlled by OpenStack. So it's basically as simple as like going to OpenStack API and either provision a new virtual machine or just rebuild the existing one and just fire up the automation to basically provision the service. But again, it all requires like the engineering time and clicking, and we all know that like engineering time costs a lot, especially like in Silicon Valley. So it's like really worth to automate, especially if you have large scale. So capacity, this one bites us a lot before. And I'm just gonna tell you what I mean about like what I mean by saying capacity planning. So for us, capacity is basically having enough compute resources for our customers, and it's like not even a big deal for us to get these resources up and running, because like we typically have a spare hardware like in the data centers, and all the automation is already in place. The like challenging part for us was to actually do it in the right time. So on the slide, the slide basically shows you how the capacity planning should look like. So you have your capacity forecast, then you go order the hardware gets received, and then the engineer can actually go and like deploy it. I mean, that looks easy, right? But like I guess almost everywhere, I think even on Amazon, it probably looks like this. So the users like report the capacity issues, then the engineers in panic trying to squeeze something out, and like after a long wait, they finally get the hypervisor deployed and fix the user's issue. So how auto-remediation approach can help in this case? In our environment, we have a capacity analyzer, which basically gets the data from the OpenStack, and it has some logic around it, basically analyze the data and detect for this data as a metrics into Zabbix. Zabbix has a triggers based on this metrics, and if the capacity gets below some level, it basically fires an alert in the StackStorm, and the StackStorm has a list of actions basically to auto-recover this issue. And this is really straightforward. It basically goes to our provisioning tool, provision few boxes, and run the deployment automation to basically get these nodes in the OpenStack tool. I'm not going to go deep in details here. The synthetic transactions are basically a functional test against your service. In our case, it's an OpenStack cloud. The synthetic transactions can be a really good partner for your monitoring tools. And it basically executes real checks and makes sure that your service works as expected. Typically, when there is no other alert being triggered, it's really hard to tell what is broken, but at least it can provide assist troubleshooting for the engineers, like sending the log files with the errors from the synthetic transaction, or maybe like the exit code from the check script, or some load balancer checks. It still can save like time for the engineers. The last but not least is that we can actually predict the hardware failure and evacuate VMs before it's not too late. And this slide basically like tells you our idea how to do it. So we have a few of the like hardware checks in Zabbix, like the check for the ECC counter, CPU temperature, some disk health checks, and networking. If one of these tests fails, it means for us that something going on with this server, and it's probably better to evacuate all the VMs to like a good node. So the Zabbix trigger an event in the StackStorm, and StackStorm again has a bunch of actions to actually recover this problem. So first, it's just gonna go and disable the hypervisor, so no one else will provision resources on top of it. And then it just can go and migrate all the VMs from the bad node. For this use case, we actually prepared a screencast that I'm just going to show you in a minute. Well, we're still polishing it, but it can give you a general idea what is the like auto-remediation process and how StackStorm can be easily integrated into it. So let's get right to it. All right, so we picked one of the hypervisor from our production OpenStack cluster. So yep. Firstly, so make sure that these VMs are actually running. All right, they are still there. That's good. So we use Zabbix as our like primarily monitoring tool. So let's go to the UI and actually check what's going on here. So we have a host group of these OpenStack compute, and you can see that there is no alert so far, which is good. The Zabbix integrated with the StackStorm through the webhooks. So we basically have an action in Zabbix that do a post request in the StackStorm API when something needs to be triggered. Now let's go to the StackStorm. The StackStorm has rules and actions. Rules are basically the conditions under which some action should happen. So for the hardware issue, we have this rule. As you see, it's tied to the action cp.evacuate VMs. So let's actually see what this action is. This action has the entry point, which is a Mistral workflow. Well, here you can see that just the YAML file, but this YAML file can actually contain the list of like actions and scripts it's supposed to be run. So let's now go to the hypervisor and actually do some sabotage. For our demo, the easiest way we can do it is basically bring one of the bond interfaces down. So we have bond 0 interface, which is our production interface. It's currently up and running. Let's check the play status. We have like two physical interfaces that actually connect to this bond. As you see, they both up. Let's bring one of them down. So once this happens, this actually triggers an alert in Zabbix. For this type of events, we have some type of grace period after which we actually consider this is the real alert. And I mean, this is just to make sure we're not gonna like migrate virtual machines just because of the networking flap or some like temporary issue. So let's go to the Zabbix UI now, and you can see that this alert actually happened. So this is our host, and it said like one or more slaves in bond 0 down. This actually triggered an event in a StackStorm. So now let's go to the StackStorm and actually check the execution list. The execution list is basically the list of executed actions that are currently either running or maybe already succeeded. So this is basically our actions that are currently running, and it's like started 24 seconds ago. Like, well, it's still like a screencast, but it still gives you an idea. It ties the action cp.evacuate VMs. So let's get some details about this executed action. As you can see, currently there is like 3 tasks. 2 of them already succeeded, and 1 of them is still running. It's basically already sent notifications into Slack and created Jira ticket, and it's currently running the evacuation of virtual machines. So let's go into Slack and actually see that like what was posted here. This is like our notification chat. So you can see that the StackStorm actually reported about the problem on this host, and one of the actions was already like succeeded. Basically, the hypervisor was disabled, and one of the VMs already started migrating. So let's actually go and check the status of the VM in the OpenStack. As you see, it's migrating. Now we can actually check the status of the hypervisor. It's supposed to be disabled. And, yep, it's disabled. And actually, there is also a message that it was disabled by the StackStorm because of the hardware issue. So the live migration of the VMs can be a long process. It typically takes from 5 minutes or maybe longer, and it depends on the virtual machine size. And it's probably like the main reason why we're showing this screencast and not as a live demo. So well, this part is a little bit fast forwarded. So we're not gonna like wait for 30 minutes or so for this migration. So as you can see, like some of the VMs have been already migrated successfully. Some of them are still migrating. So let's actually check that all of them have been migrated from the host. So the novel list shows nothing. Let's check the hypervisor. The hypervisor also shows nothing, which means like all VMs were successfully evacuated. Let's check the executed action like status in a StackStorm. So you can see the like overall status. It said succeeded, and the task list is a little bit extended. So evacuation has succeeded status, and there is also email notification that has been sent. So we can just go and check what we have in the emails. This is our like template for that type of recovery messages. We have a Jira link to the Jira ticket that has been created. We have a description of the problem. We have an action that has been taken, and basically the result of the action. We can even go to the jury ticket, and well, this is kind of like supposed to be a detailed ticket, um, like saying that we have a problem with this host. Right. So that's, I guess, all we have for today. And oops, yep, second time. And I think it's a good time for Q&A.
So my question is more regarding to the StackStorm. D Does it have a HA mode? Like, so if we are kind of orchestrating multiple actions and then the host or the node which is running the orchestration of all these remediations, if it dies in between, does it resume or does it like switch over to any other active node which is there and then continue the remediation?
Is the question about if the StackStorm has the HA mode?
HA mode, yes. So StackStorm received an event and then, or the alert, and then now we have all these remediation steps defined, right? And then, as you said, it could be a long running remediation, like the remediation could go on,
right,
and multi-step. So what would happen if in the middle of that, the node which was managing or monitoring, is it in memory, all that remediation which is doing? And if it is like a multi-step, and then if it is after the second or the third step, that StackStorm itself ran into issues, let's assume. Then what would happen? How do we recover, or how do we go from there? Is it there a HA, or how does StackStorm resume if it, like, let's say we recover the StackStorm and then go from there?
I think about HA, Dmitry is better person to answer, but I know it's supported.
Idea about how to deploy StackStorm in an HA mode. That being said, there is one aspect of availability of, when a StackStorm crashes for whatever reason, can new events and basically new events be handled by other instances? And then there is the thing that you were referring to is more of at least one guarantee, where if an event is picked up by StackStorm, how do we have a guarantee that it will go all the way through in spite of all the different failure modes that are out there? And Dimitri, you can correct me if I'm wrong, but the at least one guarantee is, there are some holes in that, but you can definitely get higher availability of the system itself, and you'll see an instance of that based on what we've done. So you can add more to it.
Exactly as Vinay said, like they are giving us hard time for this particular thing, which we don't provide at least one guarantee. But there are two parts to that. One is StackStorm runs in high availability mode itself, and another one is the Mistral, the workflow itself. When something fails, for instance, it might be failed because of external conditions, like you won't be able to run the action because there is a short network outage. Mistral, the workflow behind that, has an ability to restart the workflow from the point of failure. So you fix what had caused that, and then you restart that. Again, like Eric here, they're running StackStorm in production. They gave us hard time for this, which we fixed. So StackStorm runs in A mode. We can restart the workflow even if the failure wasn't caused by StackStorm itself. But there's at least one guarantee for the events themselves is one of the things that we're still working on.
Thank you.
Do you guys connect to any kind of CMDB to get the information about the host itself? Like if you have some action that's common for 10 servers, but for 9 they are not. So you have a CMDB that gives you.
So the action is triggered by Zabbix, and Zabbix knows about all the hosts. And when it actually does the action to the StackStorm, it basically passes the problem which is happening and the host it's happening to. And that's why it's like we identify what host is in problem and what VMs should be used. And for the VMs, we just can use Nova to query the VMs that are running on this host.
But you don't do any kind of if the host impacts the business that's outside of the technical
I mean,
world.
every host in our OpenStack cloud impacts the business. So. Of course, it's even. I think it's even better integrated, right, with the StackStorm. It has like. Okay. Yeah, I mean, you can use everything because StackStorm supports like a webhook. You basically need to post some data to the web, like to the API, right? You can do it from anywhere. And I have, yeah, as a side note, I will present this the same talk on the OpenStack Summit soon. So I appreciate like the feedback if you can go up to me after this and just talk. Thank you.